Hello everyone, I'm Xiaogang. Okay, this is a supplementary lesson. I might have missed it when I was explaining debugging earlier. Let me cover it. After packaging, we read a configuration file. This is one of our ultimate debugging methods. The ultimate method. Why is it called the ultimate method? We call it zero bug. Because sometimes just looking at the logs doesn't actually reveal the issue. Under what circumstances can we read logs? Only when we are very standardized. We have assertions, we have print logs. Only then can we identify the problem. But many times, we might not have these. We don't know where the problem occurred, so we need to check this. It shows where it crashed, and these are still quite. This knowledge is very important. So int AB equals should be 55 divided by 0. If we look at this division by 0, there should be an exception, right? Then here at this point, let's give another one. Say A equals E. Okay, now let's execute this in the editor. Then let me show you. We need to set a break, then let's execute it. Actually, in the editor, most of the time there are no issues. Let's check if there are any logs. He actually detected this division by 0 anomaly. It seems it's not very convenient to simulate this scenario. Then let's do it this way. Obviously, at this point, he won't let you pass, because he himself knows this is a 0. So what if we do it this way? Actually, we can pull off a little trick. That is, he knows now that during compilation, he knows this place is 0. So what if I don't do it during compilation? Divide by 0 at runtime? Would you know then? Then you wouldn't know, would you? So sometimes the human heart is hard to fathom. Okay? At this point, he just doesn't know, because when I compile, how am I supposed to know what you're passing? The normal approach, there might be an answer or similar check here. It should not be 0. This ties in perfectly with our assertions. Sometimes even assertions can't prevent it. It's quite normal for this bug to occur. We're still on this map. Build this map. Then we pull it down. Here we will have a 0. Because this is easier to demonstrate. This kind of exception, okay? Then we'll just give a 0. We can take a look. See, it crashed, right? Actually, after this crash, the break mode can't be passed either. Then let's check our output log. See, integer division by 0. Okay, this kind is still relatively good. This kind of problem is relatively easy to find clearly. You can see. Find our game lamb. Then child gangs learn. Inside that, there is our project. A server for the project and the logs. Then here, this should be our latest log. We can find the latest one. Actually, it should be. We can pick it out. Maybe it's still not easy to find. It should be. In this position, let me see if I can find these environments. Oh, found it. You can see. Let's compare this place. It seems the log here hasn't recorded anything, right? Let's ignore it. Anyway, it's easy to check this issue in the editor. We can only disable it. Then we'll package it now and investigate the issue. Because sometimes the editor might have a lot of mixed stuff. This is our Gendian CPP. Don't worry about it. When packaging, we need to pay attention to. Right here. In our project 30. In project 30, there is a wooden dummy map. Specify it. Okay, we only need to package this one map. Actually, then we package. Let's just go directly into the sale. Pay attention. Actually, try to keep the hierarchy not too deep. If your hierarchy is too deep, the path will be too long and cause problems. Also, the path should not have spaces. Do not use Chinese. Do not have special characters. And all your redirectors should be fixed. Yeah, actually, we covered this in the previous 2 chapters. This is where it bakes the assets. Sometimes your assets must be correct. That is, the assets must be correctly compiled and saved. Sometimes there might be some pins in your assets. like dangling blueprint nodes. All of these other things will cause the packaging to fail. And our packaging should be quite fast because there isn't much to it. But generally, the first time you package, it takes a bit longer because it might need to bake a lot of these engine-related assets. Assets like these, okay, right here, it might still need some time. So let's, right here, I'll pause for a moment. Oh, I feel like it's finished packaging. Oh, that kind of feeling. It should be almost done packaging because I might have one of these. Remend 183 packages. Okay, then let's switch over. Okay, we finished packaging here. It only took 1 minute and 32 seconds. Let's just close it. Just close it. Packaging is complete. Then here. First, find the Windows package we built and pay attention to. You can observe there is actually nothing here yet. Let's pay attention again. Pay attention. There's this thing here. Note this. These are some tools. You see? That's it. It can help you fix UX runtime environment. Very useful. Then we manually run. This is our place. Batterize. You see, this is a structure after packaging. These structures are useful after hot reloading. Sometimes you find missing DLs after packaging, especially third-party libraries. You can manually consider fixing it. Later, we will explain the standard way to place third-party library DLLs. And this is a pack. Then you can open the pack to see what assets are inside. Okay, then we will double-click to run it. For convenience, press Alt and Enter. Here, we click Allow. Good. Actually, there is some deeper knowledge here. We won't cover it here. Now pay attention to this area. Then there is a save here. And here there is a config. Windows here, there are some settings. So here, you can change the default resolution. You can see some settings regarding count can be adjusted here. And now here, there is a log. This is the log from its first startup. You see, everything is normal. No issues at all. This is PSO. This PSO is very critical. Good. Okay. So now we will press this. Seems like it doesn't seem to respond. Let's check again. Then let's add something. Add a log because we're not sure what the situation is right now. Let's add a log and see. This bug is so hard to reproduce. When you're not paying attention, it crashes often. Now that you want it to crash, it won't give you the chance. Right. Okay, let's save here. Then we repackage this. And we still put it here. Okay. We have finished packaging now. Then we can launch it directly here. Okay, see, this time it defaults to a window because we saved it before. Obviously here, it has an abnormal initial spirit. It seems it didn't record it. Let's check again. This day. You can see this group is dirt. UD here. You will find that after we press 1, it didn't record any abnormal behavior. Right. This might be excellent. It has protection. Then we have no choice. We can only do something a bit more clever. You can do this here. You can clearly see this anomaly appear. Right. Okay. Then you like this. Then we can only resort to some tricky operations. This way, this exorcism anomaly, if it cannot be reproduced after packaging, we will try a different approach. We call it AsyncTask run. Okay, here we still do it this way. And here we do it like this. We accept on thread. Here we give an on thread. And this thing is very important. In the chapter on the object layer, we will explain in detail how to use it. That is how to use this Tesca chart. But the underlying stuff is too complex. You see, there are several threads here. So the most commonly used one is the game thread. See, our any thread. It's actually just any thread, as long as it's idle. It can take on this task. Okay, we haven't finished writing this part. AsyncTask. Okay, so we'll perform some erroneous operations here. Here we need to supplement this rest pointer. Then here we can print a log. Actually, don't print the log here. There will be issues here. I'll write it for you. Don't print the log here. This place is just for testing convenience. Then what do we print here? Print the warning. Dangerous operation, non-main thread operation on actor tag. Okay. Remember to add a semicolon here. Let's format it. So this is actor location. We can see here it does a series of work here. Then we ignore it. We give an fcan. Let's just give it 100. Okay. Then, actually, if you operate it once here, let's test it and we'll know. We can make a negative loop. We make a while loop, while true. Then we might need a platform. Plan from process. This is a platform. Then we slip. Note that this slip is a bit different. It takes seconds. We give it 0.1 seconds. Look, this comment here. Look at it. Well, he hasn't navigated there yet. This part, it's for Windows, but actually it's cross-platform. Okay, so we'll modify this position in 0.1 seconds. For this position, we can change it a bit. This way, we can give it a variable. Give it a variable, stated enter, location, add. Let's set it equal to 1. The other person clicked the wrong thing, sorry. Okay, here, every time it comes, let it increment itself. Actually, this is a very dangerous operation. Yes, and here we'll edit up. Let's add it to the z-axis. That way, it's easier for us to. Okay, let's start it up now. Actually, this part isn't quite right either. This part will keep executing. This is a very typical incorrect way of using multi-threading. I'll note it down for everyone later. This one has grown a bit too long. Okay, then we'll still be here. This object in our scene. Let's move it to another position. Let's put it on the face. Then let's add something to it. Add a cube. Okay. Then at this point, we save it. Then let's drive it using the 2 key. Using the 2. And here we'll write this for it. Let's see what this is called. State location run. To make it easier for us to see, we only execute it once. Because running it online to cause more problems. Save it. I'm not really sure either. I wonder what the result will be now. Press do. Let me take a look. Ensure incoming contents. This place will report an error. You'll notice this place says ensure. Ensure, right, although it is still moving. But actually this will cause problems. You can see that although it is moving, you shouldn't do it this way. Then an error is reported here. When you exit. Okay. So this is a multi-threading error. Then after we package it, let it test. Let's see if this dump file will be generated. Let me tell you about this dump file. Where I often encounter it. It's often when we manipulate memory. That's when we are most likely to run into this problem, especially the excellent baked assets. Because of different engine versions after baking, the compression method and the way it is stored are different, and often if you cross engine versions to read assets built from different engine versions, then when it reads an asset, it will directly override it. Then you set a breakpoint, and you will find it breaks into some baking related code related to baking content inside the code. Okay. Actually, the second packaging will be very fast. That's why a packaging machine is usually needed. We still only need this side to execute. Okay, press 2. You can see that I am already frozen now. It's already frozen. This process is already frozen. But I'm not sure if it generated a dump file. Let's close it. This means the process is already frozen. We have to close it this way. Let's close our own one first to avoid duplication. Close it like this. Let's check if there is a dump file. Finally, it's here. It's here. It was really not easy to get 2 of them. So how do I use this pawn file? It's like this. And actually you also have a log here. You can see we pull up this log. You can see in this place. You can see a whole bunch of stuff popping up here. Actually, someone with more experience looking at this, they would know roughly what kind of problem you have. You can see in this place. There will be some issues when it executes this carcass. This place is right here. T function, this SetActorLocation run. There's an error in this lambda. Then it actually looks like it should be blocking the main thread. Then we double click it. After double clicking it, a VS will pop up. Then in this place, the icon is lightable only. Sometimes you may need to specify the location of the debug symbols. Then I can take a look. You will find that this thing looks very familiar, doesn't it? Isn't this thing the same as the one in our project? The breakpoint is at the same position. Then you can also see where it came from. You may not be able to see these places. Sometimes you may need to specify the debug symbols here. Then you will find that it crashed on this thread. You see, here it is in the background. Crashes inside the Walker County. It's not easy. Good, great. Demonstrate to everyone. This crash. So this crash, it crashes because of this reason. Look, this is going inward. You might not be able to see it here. May need some debug symbols, but basically you can locate it at this position. We are debugging which function caused the crash. Then you can check it. Then you just comment out this code, and you'll find it can run through the correct approach. The games you started here. Right, then nothing happens. So here we demonstrate how multithreading generates this dump. Quest needs to export the dump file. This is a very core, extremely important skill. Okay, thank you everyone. We'll stop the demonstration here. Then we just close it. And here, do not write it like this. Extremely. Do not write it like this. Extremely wrong. Okay, let's do it this way. That's all for now. Thank you everyone.